My name is Andrew Grimshaw. I'm an emeritus professor of computer science at the University of Virginia, and I'm president of Lancium Computing. Renewable energy, wind and solar in particular, are right now the least expensive way to produce energy in the world. And so as a consequence of that, it's literally the amount of renewables is exploding. In Texas alone, in the West Texas load zone, there's already 35 gigawatts of renewable power. In Texas as a whole, by 2025, there'll be 82 gigawatts of renewable power. Now, the challenge with renewables, though, is that they're intermittent, they're not always on, and they go up and down, in other words, and that they're congested. And what that really means is that where the generation is not where the loads are, in other words, where the people are. So you end up with congested power in these load zones, and as a result, the energy prices become extremely low.
The perception that carbon-free computing is expensive is a wrong perception that people have. The cost of power is very inexpensive in West Texas, and that's what we are leveraging to build our whole business model. So using that, our whole value proposition to customers is to provide the lowest cost of ownership.
My vision is to exploit all of that renewable power and essentially shift load, electrical load, from places that are more carbon generated into places that are renewable generated. And the challenge is you need to have loads that have two important properties. First, they can modulate, they can go up and down, and second is we can easily move them. Computing really fits that very well because all we need for a center, for a computing spot, is we need electricity, lots of it, and networking, lots of it. But the second thing we have to be able to do is we have to sort of invert the way we think about data centers. My entire career, managing electricity was very important, and we would want 4 nines or 5 nines of electricity availability. We're not going to get that with renewables. So instead of having the grid adapt to what the data center wants, we're going to have the data center adapt to what the grid's got.
The main difference between Lancium Compute's platform and a generic cloud provider is that our architecture is specifically focused towards the HPC space. So we've made a lot of decisions about the architecture that enable scientific compute workloads to get spun up more quickly. On a general purpose cloud, to get your workload running, you'd have to spin up all of the features that a traditional scientific cluster would have available to it. Data migration, job scheduling, optimization. We provide all that for you in our platform as a service, so all a user needs to worry about is telling us what workload they need to run, and we take care of the rest.
With platform as a service model, we are eliminating a lot of the DevOps IT expenses that you will have to pay, which is very expensive, to set up the clusters before you can launch the workload. We are avoiding any surprises in the cloud then. There are not many line items. We bundle all the elements, CPU cores, memory, software, everything, and give a simple price, and we are about 50 to 60% cheaper than Amazon, just on the per hour prices. If you include the IT ops cost, we'll be much cheaper. So that's the whole premise. And our go-to-market model is partnerships are very important for us. So we are partnering with Adaptive Computing, and there are so many other vendors who have thousands of applications. They are using us as the 5th cloud service provider with minimal cost.
What we're going to do is modulate our load up and down. So we've developed a number of technologies to do that, in particular the checkpoint and restart jobs and migrate them in time and space. And what that in time means is we put them down, we save the energy, we bring them back up again when renewable energy is plentiful. Space means we put them down to disk, we migrate them to another place, and then we run them there. And the important thing to keep in mind is that for every megawatt, let's say we have a 1 megawatt data center at a university, if you were to move that into a renewable only zone, you'd save approximately 5,000 metric tons of CO2 a year per megawatt that you move. So our vision then is to start with computing, but move things into areas where they're renewably dominated and reduce the carbon footprint of what we're doing. That's one good thing, but the second good thing is it reduces the cost of operation significantly. Electricity is a major cost factor for computing, particularly outside the United States where energy costs are much higher. So that's what we're essentially trying to do, is move computing into the Great Plains, into the Southwest, and be able to make it all carbon free.